All right, so part one, and the key word is and. Now I bolded it and I underlined it, right? Obviously in the exam, they're not going to be so nice, right? But usually when you hear the word and, like two events and have the word and in between, they're really asking you to multiply it. So how would you write this in the exam to get, well, full marks? You would write it like this. What's the probability of it raining? So R is for raining. And, well, this is a symbol for intersect or and on the CXC, well, almost any syllabus. And a comet hitting Earth. So in a case like this, they're asking you when this represents the word and. So it's the probability of it raining multiplied by the probability that a comet hits Earth. So you just have to multiply, and look, the examiner gave you the two values right here, right? He didn't even try to trick you over here. So it's 0.3 multiplied by 0.02. All right. So what you do is you need to multiply these two, and this is what I am getting, 0.006. All right. So please confirm it on your end. Well, at least for part two, what is the probability of it raining or a comet hits Earth? Now, like I mentioned, and even so the examiner said it clear as day on top, it's a non-mutually exclusive event. So we're using this formula over here, and it's the OR formula, right? And of course, they are asking us an OR question. But let me write it a little bit better. Remember, this represents the word and, right? So I'm gonna write it in. But if they want to know the probability that it will rain, or you have to use this symbol, the U, or a comet hits Earth. And the formula for that, well, you're seeing it down here, they just replace the A's and the B's with the R and the C, right? It's the probability that it's raining plus the probability that it's what? A comet minus the probability of what? It rains and a comet hits Earth. Now, if you realize, we worked out this portion in part one. A lot of the times the examiner will be so nice, like part one will help you with what? Part two. So let's put the values in. What's the probability that it will rain? 0.3 plus the probability that a comet hits Earth is 0.02 minus the and. I think most people could obviously get it out from here. Work it out and kindly send your answers across. And I'm getting this 0.314. I know some of you all might round it off to 2 decimal places. I don't think the examiner will have a problem with 2 decimal places, but I would take no chances in the exam. And if I can go to 3 decimal places, I will. See, they use the word and again. So when you use the word and, right, most likely it's going to be a multiplying situation. So what you're really asking here is what's the probability of it not raining? So the probability of it not raining, you gotta put a little dash on, a little slash on top. This means not raining and a comet hits Earth. So once again, this is a symbol for and, better known as intersect in Venn diagrams. So it's the probability of it not raining multiplied by the probability that a comet hits Earth. Now we know what the probability of a comet hitting Earth, sorry, it's 0.02. But we have raining, but we need not raining. When you need the opposite, in 99% of the cases, you just have to minus it from 1. So it's 1 minus 0.3, and we get 0.7. multiply these two, and you will get your answer. And the answer you're supposed to see on your calculator is 0.014. Right? For those who got it wrong, you understand your mistake? Sarah, you understand the mistake? Archie, you understand the mistake? Sorry. Right. So now we're going to introduce something called conditional probability. Don't let the fancy word of conditional probability. Conditional probability just means you're trying to assess a situation provided something else has already happened. Let me put this in perspective. Let's say one day you went to the doctor and the doctor said the probability of you dying on a normal day is 0.02. That's kind of low, right? Right? So, well, that's good news, right? Because you don't want the probability of dying to be too high. You want it to be you want it to be as small as possible, right? Now, let's say the circumstances have changed. So you leave the doctor feeling relatively happy because your chances of dying is low. But then you get shot. So someone shoots you in your, let me just say, not to get too graphic, in your shoulder. So somebody shoots you in your shoulder. Will your probability now of dying go up or will it go down, provided that you have just been shot? Somebody said it will go down. No, it will go up, right? Because you've been shot, right? So now your chances of dying is higher, right? So how would you write that in a mathematical equation? You see how the conditions change the situation? The condition here now is that you have been shot. So what is affected now? Dying. So this is how you would write it in maths. The probability of dying given, you put a little slash here. This means the word given. And I use S for being shot. So the probability of dying given that you have been shot. And there's a formula to calculate this, right? And I believe I have the formula over here, right? The formula is over here. The probability of A happen given that B has just happened. So to calculate that, right, means a different color here, is the probability of A and B, but I have the letters D and S here. So it's the probability of D and S. And you see the second letter, the letter after the slash, that goes underneath. So you're divided by the probability of getting shot on that particular day. So if I had the letter C here, C would go underneath. And just to let you know, right, when it comes to and, it doesn't matter if the D comes before the S. The probability of D and S is the probability of S and D. But the PS still has to go underneath because the S comes after the slash, right? So you think you all can work out this question for me? I think it's a pretty straightforward question. They want B/A, and I gave you some values on top here. Right? You're paying attention to this formula down here, right? But you notice the A and B, but they ask you for B and A, so they switch around the letters. So if they switch around the letters here, you have to switch around the letters in the formula as well. Right, so that's clear on the screen there. Right. Let me see what you come up with. So we want to find B given that A has already occurred. So that's the probability of B intersect A divided by what letter goes in the brackets here? B or A? Right, A has to go. Because if the A comes after the slash, that is what goes underneath. Now, remember I said B and A, right, is the same thing as A and B. Well, when you have the and symbol, it doesn't matter which letter comes first. So that means 2/3 goes on top. And the probability of A is 9 on 13. So you just have to use your calculator to divide that. So let me use my calculator, right? Divided by 9. And I am getting 26 on 27. Or for those who want to use your decimals, you will get roughly 0.96 point something, 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 but roughly 0.96. Anyone is correct today. For those who got it wrong, just let me know that you understand your mistake. Oh, and just to be fair, right? A question easy like this will never, ever, ever, ever come in the exam. This is just training wheels, okay? All right, so try this question. I'm not too sure if it has any tricks in it as yet, bro. All right, so it's conditional probability, right? Even if I didn't use the word conditional probability, well, once you see this slash over here, you know it's conditional probability. So if we start off with P, B slash A, which the examiner gave us, if we wanted to calculate that, it would be P, B intersect A divided by what? P, A, because the A comes after the slash. So we want to find P intersect B. But remember, P intersect B is the same thing as B intersect A. There's no difference there, right? How much of you all realized this was going to be a cross multiplication question? How much of you all realized that after you wrote out the formula? Right. So remember, the examiner gave you this PB slash A, that's 0.75. And this is equal to the item that we want to find. I can just switch it around one time. And PA is 0.52. So we could just simply what? Cross multiply. Anything by 1 is itself. And if we multiply these two, 0.75 by 0.52, let me see what I get. 0.75 multiplied by 0.52, I get exactly 0.39. So the probability of A and B happening is 0.39. So take a 20 seconds, take down the work question. All right. Now read this question properly. This seems to be a mixture now. You're seeing this slash, so you know it has something to do with what? Conditional probability. So you know it has something to do with this formula at the end of the day. But then I said something about non-mutual. So go back to the non-mutual formula, right? Which is this, well, you don't have to go back. I have it on the screen here. So it seems that you might have to combine these two formulas in order to get out the question. So they want you to find, oh, that's a bad color. They want you to find PA given that B has already happened. So to do this, it's P, A, and B happening divided by P, B, right? Because the B comes after the slash this time. So let's see what we have and what we don't have. Well, we have this part. If you read the question, the examiner gave us PB. PB is 0.5. Now, if we could just magically get the top part, then we could divide both of them, and then we would be finished with the question. But look at it carefully. Did the examiner in the question Did he or she give us A intersect B? Look at it properly. Did they give us it directly? I don't think they gave us it directly. Remember, if you look over here, this is not intersector, this is the U. We need the one with the upside down, we need the one with the rainbow, right? Not the letter U. But that shouldn't be a problem, because if it's non-mutual, remember I said we could use this formula. So by using this formula, maybe we could calculate what? A intersect B with a little bit of transposing. Well, what do you all think about that? So let me write down that form. Write it a little bigger here. PAUB is equal to PA plus PB minus PA and B. Keywords that I stress on. So we want to find this. I think the examiner gave us this, and gave us this. We can more than substitute in the values and transpose to find this guy here. My advice is, you how you have a minus sign here? Maybe you can take him and throw him across on the other side. So the minus becomes what? Positive. And maybe you can throw him on the other side. Right? Because now you're trying to transpose to make A and B the subject. Right? So hopefully that's a jump start on the question. So I just want to do the little switch here. I'm going to throw him on this side. So P, A, and B is on this side. So his minus becomes a positive, and you end up with PA plus PB, and you throw this guy across it, but he becomes a minus. So let's substitute in some values. PA, look at over here, is 0.6. PB is 0.5. And P or B, well, that's 0.7. So let's work that out quickly. 0.6 plus 0.5 minus 0.7. I am getting 0.4. So that means A and B is what? 0.4. We have to take 0.4 and divide it by 0.5. So the people, the 0.8ians, you are correct. Right? For the people who got 0.6, you understand your mistake? All right, so sometimes the examiner will throw in a Venn diagram, mix up with the probability. No, don't get too scared. A Venn diagram is just, in fact, when you have a Venn diagram, it does make it easier to do the question, in my opinion. So let's work out this question. They want us to work out the probability of B given that A has happened, right? So what will be the formula for that? Well, to calculate this, you need what? The probability of B and A happening, right? And then you have to divide it by what? P. And if you have A after the slash, P is the letter that goes under. Look at the Venn diagram. What's the probability of B and A? Remember, in Venn diagrams, this means intersect, right? Intersect. Right. And well, from form, this is like form 2. From this part is almost like form 2, right? That's where they overlap, right? So straight out of the diagram, you know the top part is 0.2. But what's the probability of A happening? That seems to be missing. You're going to have to look at all the values, right? And try to calculate PA. So let me see what you are coming. All right. So let's calculate how much probability is. Remember, the total has to be out of 1. You all noted, I think some of you all didn't see this, didn't see this 0.3 outside. How much of you all didn't see that? There was a 0.3 lurking on the outside there. Let's add up all the probabilities in this scenario. You have 0.3, 0.2, and 0.4. So that is how much? That's, everyone agrees that it's 0.9, but when you add up everything the examiner gave you, it's 0.9. If the probability is out of 1, how much is missing? Well, if it's, you just have to minus these two values and you're going to get the 0.1, which will go over here. So what's the probability of A? A lot of people by mistake, and I put in the wrong thing, will say it's 0.1. And of course, you'll leave the exam thinking you did the correct thing. But divide that and tell me what you get. If you take 0.2 and divide it by 0.1, won't you get 2? Can that ever be correct in a probability question? No. In a probability question, your answers have to be in between what? 0 and 1. So if we get 2, we know we did something wrong. So let's go back to a little bit of form 2 Venn diagrams here. In Venn diagrams, if I ask you for a lot of people think it's this portion, but anytime you say A, you are referring to the whole A circle, right? The whole A circle. So how much is the whole A circle? The 0.1 plus the 0.2. If I ask you what's the probability of B, in a Venn diagram question, they are talking about the entire B circle, not this portion alone, right? I don't know if your teacher had mentioned that, right? Whenever you use the word A, is the whole A circle. If I use the word B, is the whole B circle. Now, if I wanted to, let me just say I only wanted to specify the 0.4, I would have to say B only. If I wanted to specify the 0.1, I have to say A only. But I am not, for this formula, they never specify the word only. So it's the whole A circle. So you're adding 0.1 and the 0.2 to get 0.3. And when you divide this, you'll get 2/3 or 0.6666. Right? So I think I told some people they were correct, right? With the 0.3, correct. Right? All right. Right. Remember, P/B means P and A and B divided by the probability of B. The letter after the slash goes underneath. Well, for the top, it's pretty easy. A and B is this guy here. The 4 divided by 21. But we need the probability of B. Now, you notice the formula never said B only. It's B. So it's the whole circle. So we have, for probability of B, you have to add the 4/7, which is this guy, and add it to this portion as well. 4/21. Now I can use my calculator for that. 4/21 plus 4/7. And for the underneath, I'm getting 16/21. Now I can just use my calculator to divide that by using the fraction buttons, right? So it's 4/21 divided by 16/21. The answer I'm getting is 1/4. So it seems this time the minority of the class got it correct, because only a few people said 1/4. The majority was saying 1/3. For those who got 1/3, you understand your mistake? Quite a few people did get 1/3, right? All right, great. All right, so now we're moving on to a different section of probability, something called probability trees. Okay. Right. So read this question and then we're going to, right? So you have apparently you have two games here. Do you all know what the teddy grabber is? That's the thing where you insert a coin and have this kind of hand and have a kind of joystick and you just try to grab like a teddy bear and get it in a hole. Right? The kind of claw game, the claw game that you just never ever win anything in. And apparently there's another game called the penny drop. Now I have no idea what the penny drop game is. I really have no idea. But the point is, you can either win the game or you could what? Lose the game. That's how games go, right? So you have two situations here. So apparently you're playing the teddy grabber game first and then the what? Penny drop. How probability trees work, right, is when you go horizontal, like when you're going from left to right, like when you're starting here in the diagram and you're working your way across. When you do that, you multiply values. Anytime you go vertical, like you go up and down, you will add your values. Don't worry, this will become apparent just now. Tree diagrams, they're called tree diagrams because if you look at it, right, these are like branches and you have a branch here and then this branch would split up into two more branches. Probability trees help us to visualize all the different possible scenarios in a situation. For example, when you play the first game, now they're assuming that this first branch here represents the teddy grabber. When you're playing this game, it's either you win or you could lose. So let's say you win. After you win that game and you go to the next game, which is the penny drop, two things can happen again. You can either win the penny drop or lose the penny drop. Or when you now started, you could lose the teddy grabber game. And after losing it, you could either win or lose. So how much different scenarios it have? It have 4 different scenarios that can happen. If you end up over here, what does that mean? That means the only way you can end up here is if you win the teddy grabber and then you win the penny drop. If you ended up over here by the tick, that means, now here's your starting point. The only way to reach here would be to win the teddy grabber and then lose the penny drop. Everyone have a kind of a basic idea of how this is showing you all the basic outcomes of both games? Or if you want to end up over here, you can what? Either lose the teddy grabber and then win the penny drop. But the point is, you're walking from what? Left to right. And if you don't want to, you're pretending like each one is a road. And these are the different paths you can take as you walk from left to right. So let's see, but you notice some things are missing. The examiner gave you the probability of winning the teddy grabber. Did he give you the probability of losing? But shouldn't that be easy to calculate? So what value do you think will go here? If the probability of winning this particular game is 0.2, what should be the probability of losing if it only have 2 possibilities? Is that you win or you lose? Right. It should be what? 0.8. How did we get that? Remember, the total probability is out of 1. So I just minus this from 1. So let's go over here now. The probability of winning the penny drop is 0.7. So the probability of losing it is how much? 0.7. You minus this from 1. And of course, everything here is the penny drop. So the probability of winning the penny drop is 0.3 again, and the probability of losing is 0.7. Right? Right. So let's get to the actual question now. Yeah, sorry, I had to write it up here. But getting these probability diagrams to fit is a real problem. So we have just completed the diagram. So we can see where all the probabilities are located. Here's what we want us to do now. Work out the probability that James wins on the teddy grabber and he also wins on the penny drop. So in other words, already asking what's the probability that he wins both games. It only have one way he could win both games. He has to win on the teddy grabber and win on the penny drop. Remember, when you're basically going from left to right, you have to multiply all the values you come in contact with. So this question is just 0.2 multiplied by 0.3. And this will give us how much? 0.06. 0.06, check it back, not 0.6, 0.06, Joshua. All right, so you're going to see a different way, a different scenario now. So apparently this person, Natalie, has 8 socks in a drawer. She has 5, black pairs and what? 3 are white, so 5 and 3. Now, she's basically going to pick the socks out of the drawers, right? So on her first pick, right? So anything, let's draw this line, I'll erase it just now. Anything behind this line is the first pick. Anything after this line will be the second pick. On her first pick, what's the probability, set it as a fraction, what's the probability that she picks a black socks? Right? It's not a trick question, so don't be shy about sending the answers. Sadiq, why you say 5/7? Check it back. There are how much socks in the drawer? 8. Okay. Christopher, you want to check that back? Right. Shouldn't it be 5/8? Does that make sense? Because 8 are black and then have how much in all? 8. Christopher, you understand the mistake? I think you did the white ones by mistake. Right. Now, what's the probability? Remember, she could either pick a black one or pick a white one. So what's the probability of picking a white one? Well, obviously it would be what? 3/8. Right? Now here, you gotta read the question properly now, right? So apparently when she picks a socks, she puts it back into the drawer before she repicks. I don't know what game she's playing there, right? So on her second pick now, provided that she picks a black one first, and then she throws it back into the drawer, she takes another pick. She can either pick a black one or white one. Picking a black one again should be the same probability because it still have 5 black ones, and it's still 8 socks in all because remember she put it back for whatever strange reason. And the probability of picking a white one is what? 3/8. Now the same thing can happen with the white scenario. You can pick a white socks first, right? And then afterwards you have another pick. So picking a black is 5/8. And picking what? A white is what? 3/8. So that we just completed the diagram there for the examiner. Usually completing the diagram, you get about 2 to 3 marks for just completing the diagram. So let's try the actual question now, which I have to write in this strange position here. Work out the probability that the 2 socks are the same color. So let's try to visualize this. So let's pretend it's a game. If the 2 socks she picked are the same color, she wins a prize. So let me just say that. So it's two ways she can win this game. She can either pick 2 black socks or 2 white socks. Everybody agrees with that? That's the only way to win this game, is either you pick 2 black or 2 white. So let's see how that can happen. She can pick a black first, and then after, to win the game, she has to pick another black, which will end up in this position. So when you're going across, you multiply. So it's 5/8 multiplied by what? Another 5/8. So that will give us what? 25 over 64. But how else can she win this game? She can also, pick a white and then pick what? Another white. So when you're going across from left to right, you have to multiply the values. So it's 3/8 multiplied by another 3/8, which is 9 over 64. Because we're going from left to right. And left to right means you have to multiply all the values you come in contact with. So what's the total probability? Won't it be these 2 values? And remember, since it's these 2 values and I'm moving the mouse vertically, we have to add them. So you have to add this and you have to add this. These are the 2 possibilities that will lead her to winning the game. So add these 2 and you are finished with the entire question. So when you move across, you multiply. When you're considering the vertical values, you add them. You do not multiply them. Right? Now I'm using my calculator to add it up, right? So the calculator will simplify it and everything for me. So when you simplify it, you'll get 17 over 32. Right, so this one, I'm going to ask you to take down the whole thing from beginning to end. Draw the diagram, take down the question. Question holds. Oh, here's a scary looking one. Right? Right. John, I'm not too sure. I can't remember, but right. Okay, so I'm not going to make you draw this one, right? We're just going to work it out together. I could see this causing some problems to draw and to make it fit in your arm, right? Right? Draw this. So apparently, in this scenario here, right? You can either, it's 2 matches you're going to play, one after the other, apparently. So you can either win, lose, or draw. So when you now start the first game, you can either win. The winning probability is 0.6. The draw-in probability is 0.3. So what's the probability that you lose? How does that look? Right. You add up these 2 and you minus it from 1, because the total probability of this scenario, well, the probability of the vertical scenario here is supposed to be 1. So 0.6 plus 0.3 is 0.9. You minus it from 1, you'll get 0.1. And of course, if you can either win the first match, and after winning the first match, you begin the next match. And of course, the same possibilities are put forward to you. You can either win, draw, or lose. So once again here's 0.6, here's 0.3, and here's 0.1. Right? 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 All right. So you can draw, and after you draw, you can either what? Win, draw, or lose. So here's 0.6, here's 0.3, and here's 0.1. And the same thing here, 0.6, 0.3, and of course, you have what? 0.1. Right? Everyone okay so far? Once again, I'm not asking you to draw it, but just let me know that if you're with me so far, right? Just with me so far. Right? I'll probably ask you to screenshot it after. Right. All right, so let's see if we can answer the first question, part 1. Find the probability they will lose and win one match. Now, let's read this statement carefully. Yeah? And this is where the tricks start with the grammar. So if I come and ask you, what's the probability that they will lose and win one match? Does that mean you have to lose the first match and win the second match? Or the order of winning and losing doesn't matter? Which one is it? Which one is it? Does the order matter or does the order not matter based on the structure of that sentence? So some people saying win, then lose. Some people saying it doesn't matter. It doesn't matter, right? And I know this could be a little tricky, right? Because like me, I real horrible at English, right? Real horrible. So me interpreting questions, it just take a while to sink in, okay? But I'm letting you know it doesn't matter. So that means you could lose first and then win, or you're going to win first and then lose. But the point is you have to win one or lose one. So let's see the different possibilities. I'll put it in different colors here. Green. So it seems that you can do what first? You can win first, and when you reach the next match, you have to lose. So you win and then lose. Now you're still going pretty much horizontal from left to right. Or you can lose first and then win. I think those are the only two possibilities. So if you win and then lose, it's 0.6 multiplied by 0.1, because essentially we're moving from left to right. So we have to multiply the values we come in contact with. 0.6 multiplied by 0.1. 0.6 multiplied by 0.1. I think this will give us 0.06. Or, right, we can lose first and then win. So over here is 0.1 multiplied by what? 0.6. This will give us another 0.06. So what's the total probability now? There are two possibilities, this one and this one. So you have to add those two. So it's 0.06 plus another what? 0.06. And I think, well, you all will get the answer on the calculator there. How much? 0.12. I hope that's correct. I didn't use my calculator there. Right? Right. So what you're going to have to do, screenshot this one. I'm not going to ask you to draw this, right? Right. No problem, Michaela. Find the probability they will lose at least one match. And this is where the grammar is going to catch you, right? Let's talk it through, and then you're going to try to work it out. Find the probability that they will lose one match. What does that mean? That doesn't mean they're going to lose exactly one match. You know, they can lose one match, but they use the words at least. So that means they could lose one match, or they can lose how much? 2 matches, right? Oh, you're right. They can lose one match or more, but it's only 2 games they're playing, right? So the maximum amount of matches you can lose is 2, right? So if you play 2 games and you lose more than 2, that is like almost like an impossibility, right? You gotta be like a real terrible team if you think about it. It's not even possible, right? So do you all think you all can draw the lines to represent all the possibilities of losing at least one match and send the final answer across? You can just trace it with your fingers and calculate the values. See, we have a different colors here, starting with a blue. So I think you could win the first match and then lose the next match. That includes a loss. So you can either lose 1 game or 2 games. So this scenario here involves 1 loss. So that one is okay. So over here will be 0.6 multiplied by 0.1, right? So 0.6 by 0.1 is 0.06. So that is one way it can happen. What's another way it can happen? Well, couldn't you draw the first game? And then after drawing the first game, you lose the next game? To me, that involves 1 loss, at least 1 loss. So it's 0.3 multiplied by 0.1. That's 0.03, right? If you multiply these two. Or you can do what? Lose the first game, so that is 1 loss, and win the next game. But that still involves 1 loss. So that is okay, right? So it's 0.1 multiplied by 0.6, which is 0.06. Or, we got a different color here. You can lose the first game again and then draw the next game. I think some of you all missed that. You could lose and then draw. That's still 1 loss, right? You still lost 1 game. So it's 0.1 multiplied by 0.3, which will give you 0.03. But remember, they use the word at least. So you can lose 2 games also, which means you can lose the first game and lose the next game. So it's 0.1 multiplied by 0.1, which is 0.01. Did I miss any there? Nah, I don't think I missed any there. So add up all of these values now, all of these vertical values. 1, 2, 3, 4, 5. Let me add them up here. 0.06 plus 0.03 plus 0.06. I'm gonna mess it up. 0.06 plus. I get in this 0.019 for my final answer.